Yes, good morning to all. Am I audible?
Yes, sir. Good
Okay,
morning, sir.
good morning.
Morning, sir.
Yeah. Uh, so, yesterday we were discussing the polynomial program, operations on the polynomial. Okay, that is evaluating the polynomial and then adding two polynomials. This is what we were discussing, and most of the things we have already discussed. Okay. Uh, So the various functions here are read poly. This is one function. Ashok, Ashok. Okay, read poly is one function, and then poly add p add is another, and poly eval attach. Attach is the function which we call in order to add the node to the circular singly linked list, and then for printing we use polyprint, and all these things we understood in the previous class. This case 1 is for evaluating the given polynomial, and finally we print its result, and case 2 is for adding two polynomials. Okay, now here, yeah, okay, now here, yeah, read poly, and this also, this is what we were discussing yesterday, polynomial adding. So we take two polynomials p1 and p2, and then we make start a and start b to point to the same polynomials. Start a is pointing to the first node of the polynomial p1, and start b pointing to the first node of the polynomial 2. And then what we do, we allocate the memory for the resultant polynomial node, and then we make the link field of the resultant polynomial to point to itself. And then since we have already made start a and start b to point to the header nodes or the starting nodes of the p1 and p2, now p1 and p2 can be incremented and made to point to the next node. Okay, and here while p1 is not equal to start a, so because since it's a circular singly linked list, so since and you need to travel through all the nodes of the singly linked list. Now how do we check whether we have traveled all the nodes of the singly linked list or not? Now this is how we can check. Okay, right now start a is pointing to the header node, and p1 is pointing to the next node after the header node of the first polynomial, and if p1 not equal to start a, that means I have not reached back. Okay, so I am not completed one cycle. So, and then similarly p2 not equal to start b. Now we go for checking these conditions and act accordingly. Now what is the first condition we check, as it was shown to you people in the presentation? Okay, first thing you need to check is checking the equality of the exponents. If the exponents of all the variables are same, then we add the corresponding coefficients. Now what I am doing, since we have three variables here, x, y and z, now I take the exponent of the x from the first polynomial. I am comparing that with the exponent of x in the second polynomial, and similarly y exponent of the first polynomial is compared with the y exponent of the second polynomial, and then z exponent of first polynomial is compared with the z exponent of the second polynomial. If all of them are same, so then we add the corresponding coefficients, and then if you have some, then we go for attaching. So to the resultant, where we are attaching, when I say attach, it is to the resultant polynomial circular singly circular list. Attach the sum what you have obtained by adding the corresponding coefficients, and then you attach any either p1's exponent or p2's exponent, anything is fine because all are same. Okay, so p1 exponent, here I have written it as p1 arrow x, p1 arrow y, and p1 arrow z. So these all represents the exponent of x, y, and z. Since they are same, either you can go for writing it as p1 arrow x or p2 arrow x and p2 arrow y and p2 arrow z. So, but it should be attached to the resultant polynomial and that is p3. Okay, and after doing this, okay, if the exponents of all the variables are same, we add the corresponding coefficients and we attach it to the resultant polynomial, and then we go for incrementing both. This is what is important. We increment both p1 as well as p2. Okay, so p1 was pointing to the first node after the header node, and p2 was also pointing to the first node after the header node. So now they should be made to point to the second nodes after the header node. Okay, so this is what we do. If this condition is not true, it is an if else ladder. If you observe just here, it is an if else ladder. If this condition is not true, okay, if any one of the condition is false, so then we go for checking with this condition. What we are doing here, we are checking whether the exponent of x from the second polynomial, yes, mute, uh, 191 USN 191 191. Okay, now what we are doing here, I am just checking whether the exponent of the first polynomial x, first the exponent of the variable x of the first polynomial p1 is lesser than the exponent of the second polynomial with respect to x. So if this is true, then what we do, we again go for attaching the coefficient of 2. Always you should go for choosing or attaching the coefficient and the exponent, attaching that term which has the highest exponent. Since I am saying the exponent of polynomial p1 with respect to x is less than the exponent of the polynomial p2 with respect to x, so now what I do, I go for attaching the p2's coefficient and p2's exponent of x and p2's exponent of y and p2's exponent of z. OP people understood with this?
Yes, sir.
Yeah, and similarly,
Yes, sir.
yeah, so we checked here the exponent of p1 is lesser than the exponent of p2. So similarly, opposite we do here. Else if the exponent of p1 with respect to x, if it is greater than the exponent of p2 with respect to x, then what we do, we attach the p1's coefficient and then the exponent from the p1 and for all y and z. Okay, and this is another thing, since p1 was higher here, p2 was higher, so only p2 is incremented, and here p1 is higher, only p1 is incremented. And similarly else if, okay, so here in this two else if statements, I'm comparing the only the x component. So now I am going for comparing the y component. So if y is the exponent of p1 with respect to y is lesser than the exponent of p2 with respect to y, then what is that I need to attach? Again p2, p2's coefficient and all the coefficients from p2 itself, and increment only p2. So if the exponent of p1 with respect to y is greater than exponent of p2 with respect to y, so then we attach p1, same as this. So this is one more else if statement, and similarly two more else ifs you need to write. Now what are those? These two. Okay, again with respect to z you are checking, and again you are checking with respect to z. You are checking whether the exponent of z component from the first polynomial is lesser than the exponent of the z component from the second polynomial. If this is true, do this, attach P2's coefficient and all the exponents from the P2. If this is not true, then go for attaching the P1's coefficient and all the exponents from the polynomial P1, okay, and increment appropriately the pointers. Next, now after doing all these things, okay, if still P1 is not equal to start here, so say for example some polynomial, say the polynomial 1 might be smaller, might have smaller number of terms than compared to the polynomial B, and sometimes the polynomial A and B, they might have the same number of terms, and sometimes the polynomial B might have smaller number of terms than compared to the polynomial A. So finally, when you reach the end of the polynomial, okay, say for example I have reached the end of the polynomial 2, but still there are few terms which are present inside the polynomial 1. Now what I do, I run a for loop for P1 until P1 not equal to start A. So what I do, I take the coefficients and the exponents of the polynomial 1, I simply attach it to the resultant polynomial P3. And similarly, in case if the P1 polynomial is smaller, has smaller number of or fewer number of terms than compared to the P2 polynomial, so next again until P2 not equal to start B, I go for attaching every term of the polynomial P2 to the resultant polynomial, okay, and finally return P3. This is what we do. Attach, I think I've already explained you people. Evaluate polynomial was also explained in the previous class. Yeah, now print poly is another function which we need to discuss. Okay, so print polynomial. Now after adding, so we got to print the resultant polynomial, which is nothing but P3. I'm calling print poly by passing P3 as the argument. Now if I come here, so print poly function, yeah, this one. Now again what we are doing is I have taken one more pointer Q, and that Q I am initializing it to add arrow link. So header will be pointing to the first node, okay, the first node is the header node, and very next node is the node which is holding the resultant polynomial, okay. Now Q is equal to header arrow link. When I say the Q is pointing to the next node after the header node, okay, and running a do while loop, so and printing the coefficient, okay. So I print the coefficient. So this percentage D is the placeholder for printing the coefficient. So I am doing Q arrow coefficient, okay. So this is the place, so this percentage D is the placeholder for the coefficient, and then X, I have the variable X, and this cap, the caret symbol is the exponent symbol, okay, and for the exponent I am printing here Q arrow X, and then I have percentage D again, okay, which is the placeholder for the coefficient of what, Y, okay, yeah, coefficient of Y, and then sorry, no, not coefficient, this percentage D is the placeholder for Q arrow X, just to print X to the power so many things, and then Y to the power, this percentage D is the placeholder for Q arrow Y, which is the exponent of Y, and this percentage D is the placeholder for Z, which is the exponent of Z, okay. And then finally after printing one term, so this printf statement is going to print a term of the resultant matrix. So next, to print the next term of the resultant matrix, resultant polynomial, I say Q is equal to Q arrow link, okay. So Q gets, and this process is repeated until Q is not equal to header. The moment the Q is equal to header, what does it mean? I started all the way from the beginning of the circular list, reached the end of the circular list, I'm back to the header node of the circular list, and then I have to stop the process. So hope you people understood. Any doubts in this?
No, sir.
Okay.
No, sir.
Now we'll go for executing this program. Okay, DOSBox emulator has stopped working. Okay, I don't know what to do. So this is not opening for me. I think I have to restart my laptop, but restarting, if I restart now, it will take around 20 minutes to restart. So can any one of you, those who are connected either through desktop or laptop, can you do me a favor? Is it possible for you to share the screen and open the program from your end for me? Any volunteer who has joined with the desktop or laptop? Yes. Nobody has joined to desktop or laptop. So please respond.
I've gone with laptop, sir, but I don't have Turbo C++.
You don't have Turbo C++. You have code blocks at least?
No, sir, I'm using an online compiler.
Online compiler. Anything is fine. If you have code blocks or the Turbo C, those who have installed, can just inform me, please. I'll make them as presenter. Just open the program is already there. Yesterday I've uploaded it to my Google site. You can download the same and try to open the program in either in Turbo C or code blocks and share the screen to me. I hope one of you can do that. Oh God, nobody wants to do. Okay.
Sir.
Yes, man. Hello.
Yes, sir.
Yeah.
350.
Okay, 350. I'll make you as the presenter. 1 second. So I'll try again opening. If it opens here at my laptop, it's not necessary. Okay. 16 CS 350. No.
Yes.
Yeah. Thank you, man. Yeah, I've made you as a presenter. Just try to share. Download the program from my Google site, open it and try to share. So meantime I'll check again whether so I think I have to stop sharing my screen. I'll do that. Okay, no, it will not. Okay, I'll stop sharing, and USN 350 you can share. Yeah, go for sharing. Okay, thank you. Uh, yeah, all of you can see the screen.
Yes, sir.
Okay.
Yes, sir.
Now I'll USN 350. I'll request a control. You just grant it to me. Okay. I think I can remotely control from here also. So there is a request sent. Just try to grant. Did you got? USN 350. Yeah. Okay. No, not there. USN 350. Just do escape. Escape you do. Okay. Now I think you've given me the control. Let me try. Don't do anything from your end. One second. Don't do anything. You don't operate, please. I'll try to do it by myself. Okay, it's working for me. Okay, so this is the program. Only thing is I'm not able to use the mouse, but through keyboard I can control a screen. Okay. I think mouse is not necessary for me. Okay, now let me compile this. Okay, so Alt C. So errors are 0, but there are still 5 warnings, so we can ignore them. Code has no effect. Warnings are there, but let us not worry about it. So Alt R, I'll go for running the program. Okay. Saying code has no effect. Why? Okay. So now enter the choice 1. I'll go with 1. Now enter the values of x, y, and z. Okay. I'll go with 0, 0, 0 first. 0, 0, 0. I've given all zeros. So the saying domain error it is giving because 0 I've given. The polynomial result is 0.00. Okay. So let me try with another input. Okay, choice 1. Now I'll give 1, 1, 1. So result of the polynomial is 5. Okay, that I'll come to know. Let me go to the program. So by pressing 3 and exit. Okay, now here poly evaluation. See here, you're calling eval poly here. Okay, so let me go to the function evaluate polynomial. Yeah, this is evaluate polynomial. Now what we are doing here, we are reading this x value, y value, and z value, and this is what we have taken. Okay, so these are the coefficients, and for the number of terms which is here, n is equal to 20. What we are doing, we are taking each term. Okay, we are attaching it to the list. We are creating the singly linked list, and then I'm taking the coefficient. So inside the while loop we can just observe here. So 20 terms are here, and this is the coefficient of the first term, this is the coefficient of the second term, third term, like this. And next what we are doing here is this one. Take the coefficient and then find the power. Okay, x value to the power this. Okay, so and y value to the power this, z value to the power this, and we compute the whole value here, and then finally we are going for printing. So I'll debug this program, you'll understand. So but now, as of now, we'll try to execute it for both the cases, and then we'll try to do the step by step execution. Okay, now again I'll run it. Okay, now I'll go with the case 1 again. Now when I debug the program, you'll understand why you are getting it as 0 and why you are getting it as 5. All those things you will understand. Now I'll give 2, x value 2, y value 2, and z value also as 2, and the result of the polynomial is 2 to 4. Okay, now we'll go for the choice 2. Okay, choice 2 once again. Okay, enter the polynomial a. It is asking me. First I have to enter the coefficient, and then the x exponent, y exponent, and z exponent. I'll take the coefficient as 2, and x exponent as 3, y exponent as 4, and z exponent as 5. Okay, now again it is asking me enter the coefficient and x exponent, y exponent, and z exponent for the polynomial a, second term of the polynomial a. So what you are observing here is this is 2 is the coefficient, and this is the exponent of x, exponent of y, exponent of z. And similarly for the second term it is asking. For the second term I'll give the coefficient as 5 and exponent as 2, or let me take 3, same 3, 4, 5, because all cases I need to show you. Okay, I have taken the different coefficients. Okay, I have taken different coefficients, but the same exponent I have taken. Okay. Now enter one more coefficient, 6, and then I'll take 1, 1, 1. Okay, and one more, 4, 2, 2, 2, 2. Okay. Oh, I have given one extra. 3. Okay. 1, 2, 3. Now when it will read? Okay, one more. One second, let me go back to the program. So it is reading all the polynomial terms for the polynomial A, but when it will read, one second, let me check the program. So running into an infinite loop, control break. Yes, USN 350, can you do control break from your end? Are you doing it? Hello? Am I audible? Yeah, USN 350, just do control break, press control break from the keyboard. Okay, do one thing, right click and close and open again. No, it has to read a few terms for the polynomial A, and then it should go for reading the terms of the polynomial B. That is not happening. I need to check the program. Yeah, close it. Yeah, close and open. Or wait for a while, don't share, let me share from my end itself. The program I'll see now, okay, because it has to read few terms and then it should go for reading the terms of the polynomial B. That was not happening. Let me check. Okay, so read polynomial. Okay, we have written it inside the infinite while. That's the reason. See what we do here, enter the polynomial A, then it makes a call to read poly P1, okay, and then what it does, it comes here. So okay. Now have you people understood how to stop it? See, by looking into this while 1 we have written, that means this is an infinite loop, it repeats forever. OP people are following? Now if I want to stop the terms of the polynomial A, what is that I need to do? See, look into the statement. The exponent of x, I need to enter it as what? Can you people see this? What is this value is? -1. See, if I want to stop reading the terms of the exponent A, what is that I need to do? If exponent, I should go for entering the -1 value for the exponent of x. The moment I enter the -1 value for the exponent of x, it breaks and then it will go for reading the item of terms of the second polynomial. OP people understood? Yeah, okay. Now we'll just go for the execution. Yeah, USN 350. I'll stop sharing my screen. Go for sharing your screen, and I'll request the control grant the permission to me. Okay. Yeah. Yeah, I've sent. Okay, I've received it. Okay, thank you. Can you maximize it? Drag it to the left. Okay, enough. Okay. I'll do from here. Okay, now we'll go directly to the second choice. Enter the polynomial. I'll take 2 as the coefficient and 3, 4, 5 exponent. Okay, now second one, I'll take 3 as the coefficient. I'll take the same exponents for x, y, and z. 5. Okay, now again it is asking, say I want only 2 terms in my polynomial a. Okay, what I'll do is I take some coefficient 4, and now to terminate I have to give -1 for the exponent of what? X. Okay, and then this you can give anything. Now what happens if I press enter? So this is not taken. Okay, now enter polynomial b. Hope you understood. Okay, now I'll go for giving the polynomial b. So I'll take coefficient as 5, and I'll take the same exponents here also, 3, 4, because I just want to go with the first case. Now again I take 6, and then 3, 4, 5. Now only two terms are enough, I think. Okay, this 7 I'll take, and now I need to terminate. -1 I'll give. So this you can give anything. Now it stops even reading. Okay, see now the resultant polynomial is this. How this is found? Observe now. So take the first term of the first polynomial. Okay, that is 2, 3, 4, 5. So first term of the second polynomial, 5, 3, 4, 5. So the exponents are same. Here it is 3. Can you see my mouse movement? Hello? Yeah, my mouse movement, can you people see on the output screen? Yeah. So is it visible? Just observe now. Please speak. Visible, okay. 3, see 3, and here also it is 3, same. So 4, 4, same. 5, okay, it's visible, and so I think on the output screen you cannot see the screen, the mouse pointer. So just look here, listen to me. So in the first term of the polynomial a, what is the first exponent? Reply back. What is the first exponent? In the first term of the polynomial a, what is the exponent? 3. What is the exponent of the first term in the polynomial b? 3. They are same, correct, right? This is the condition what we used to check, correct, right? And then what is the exponent of the first term? exponent of y in the first term of polynomial a. 4. What is, no, 4 it is. Y exponent 4. So what is the exponent of y in the first term of polynomial b? 4. They are same, correct, right? So 3 conditions are there, 3 inds were there. You people remember the program? Yeah. And similarly, the y exponent of the first term in polynomial a, that is 5, and the z exponent of the first term in polynomial a and z exponent of the first term in polynomial b are same. Now if they are same, what is that you got to do? You got to add the corresponding coefficients. So the coefficient in the first term of the polynomial a is 2, and the coefficient of the first term in the polynomial b is 5. 2 plus 5 is how much? 7. So in the resultant polynomial c, what you are seeing is what? 7. And x to the power 3. So you attach either the exponent from the polynomial a or from the polynomial b, correct? No, because both are same. So 7 x to the power 3 y to the power 4. What I am reading is the resultant polynomial. Look into the resultant polynomial. 7 x to the power 3. How do we represent power? We are using the caret symbol. 7 x to the power 3, y to the power 4, and z to the power 5. So since both the things were same, correct? No? The first condition is true. In first condition, what we do? If all the exponents are same, we go for incrementing both a as well as b. Yes or no? Now we have the pointer p1 in the first polynomial pointing to the second term, and similarly we have the pointer p2 pointing to the second term of the polynomial b. Now if you just observe the second terms of both the polynomials, the exponents are same again. Is it same? Yes. Now what you got to do again? So you got to add the corresponding coefficients. So the coefficient of the second term in the polynomial a is 3, and the coefficient of the second term, second term in polynomial b is 6. 6 plus 3 is 9. Okay, you're getting 9 x to the power 3, y to the power 4, and z to the power 5. Understood? No? Now similarly it goes with the other cases also. So we need to input the terms of the polynomial appropriately and check for the other cases also. Okay. So if the system is working from my end, it would be fine, but I think now again, okay, what I have to do is I have to take the choice 2 and then go for giving the appropriate terms for the polynomial a and polynomial b and go for checking the output. Okay. So one case I'll take. So again I'll go with 2. Okay. Now what I'll give is, let me take the coefficient as 2. Now the polynomial x, I'll take it as 3. Observe. And then this is 4 I'll take. This is 4 I'll take. 5. Next, second term of the polynomial. Okay, I think yeah, we'll take one more term, 3. Now what I'll do, this one I'll take 1, 1, 1. Now I need to end my first polynomial. Some coefficient I'll write, and for the x exponent I'll put it as -1. So remember this, okay? So don't get confused. Now I have terminated my polynomial a. Now I'm going for reading the polynomial b. 1 coefficient. Now what I'll do, intentionally I'll go for entering the exponent of x. Okay, x exponent in polynomial b lesser than the polynomial a x exponent. So let me give it as 2. So 2 is less than 3, and then I take it as okay, 4, and then I take it as 5. Okay. Now other one I'll take it as 2, and here also see the exponent of the second term, x exponent in polynomial a is 1. Now I'll go for giving it as 0 here because I want to take it as less, and the other two I'll retain the same thing, 1 and 1. Okay, now I terminate my second polynomial also by giving -1 to the x coefficient. So other things are not necessary for us. Now you observe now. See, can you people observe now? We have got the resultant polynomial c. So how we got this, correct? No? That is what you need to explain. So say I'll try to explain. So I am taking the exponent of the x from the first polynomial. So exponent of x from the second polynomial. Now exponent of the first term in the a polynomial is greater than the second. Now what we got to do? Now I got to retain the coefficient of what? See, what was the coefficient of the first term in the polynomial a? 2. Same thing is retained. Able to see? Yeah. Now since the x exponent of the first term in polynomial a is greater than the x exponent of the first term in the polynomial b, now I should go for retaining the same term from the polynomial a. Okay, so same thing you can see, its coefficient is retained, that is 2, and x to the power 3, y to the power 4, and z to the power 5. All exponents are from the first term of the polynomial a. Is that clear? And what we do, we go for incrementing only a pointer. Okay, a is made to point to the next term now, that is 3 1 1 1. Okay, 3 1 1 1. What about b? B is still pointing to what? The first term, that is 1 2 4 5. OP people are following? This you'll understand if you try to relate this with the code what I've already explained. Okay, so a is pointing to this 3 1 1, whereas b the P2 is still pointing to 1 2 4 5. Next, when you are comparing, what you are doing, you are comparing again yeah, so this one, so exponent of x exponent of the second term from polynomial a, that is 1, because a is incremented, and the next term from a is this 3 1 1 1. So this one we are comparing with x exponent of b in the first term, that is 2. Which one is greater here? Which one is bigger? 2 is bigger. Now in the resultant polynomial, which term you should have? You should have the term from the polynomial b. Now the term from the polynomial b is this. Okay, so you can see here 1 is the coefficient, and x to the power, and all coefficients of the b polynomial are retained, x to the power 2, y to the power 4, and z to the power 5. Hope you understood. Okay, now a is still pointing here itself. In the polynomial a, the pointer is pointing to what? 3 1 1, and b gets incremented now. Okay, b gets incremented, and it is pointing to 2 0 1 1. Correct, right? 2 0 1 1. Now when I compare these two, see, in a polynomial the pointer is pointing to 3 1 1, and in b pointer the pointer is pointing to 2 0 1 1. Again go for comparing the exponent of x in both the terms. So exponent of x in the polynomial a is 1, and the exponent of see, if you're able to see my mouse movement, it would have been better, but unfortunately you cannot see my mouse pointer movement, but you have to follow me when I'm speaking. So exponent of a in a polynomial is 1, and exponent of a in b polynomial is 0. Now which one is winning? So the a polynomial is winning, and you can see here the resultant matrix, you have 3, and all the exponents of the a polynomial are retained. 3 into x to the power 1, y to the power 1, and z to the power 1, and then what? Increment a, but this is the end of the polynomial a. Okay, and next what you do, you take those two for loops which we wrote after checking all the conditions, correct? No? So in that, so the second for loop, what it will do, it will go for attaching all the terms which are remaining in the polynomial b. So this is the only term which is remaining, that is 2 into x to the power 0, y to the power 1 and z to the power 1. OP people understood with this? Okay. So when I debug, you'll understand the program. Okay. So debugging, let me do later. Okay. Now we will stop here. I hope to some extent you people understood. Once I debug the entire program, so you'll clearly understand this. And I've already posted this for you to go through the program, and if you when you are going through the program, if you get any doubts, please make a note of it, and when I come next tomorrow, so please do ask your doubts. I'll try to clarify. Okay, I'll exit the program now, and I thank USN 350 for sharing the screen and helping me in continuing my class. Okay, thank you, man. Okay, now I'll take attendance, and we will end the class here, and tomorrow for half an hour let me trace this program, and then we will continue with our fourth module, that is trees. Okay. So SS 350 is there, 43, 135, 156, Sri Jita absent, 10, 39, 116, 134, 135, 136. Oh, sorry. One 38, 140, 141, 142, 143, 144, 145, 146, 147 Shubham Kumar absent, 148, 149. Okay. One 150, 151, 152, 153, 154. Sufyan absent. 155 is there. 156, 157, 158, 159, 160, 162 absent. 163 absent. 164. 165, 166, 167, 168, 169, 170 absent. 171, 172, 174 absent. 175, 170. 176 present, 177, 178, 179, 180, 181, 182, 183, 184, 185, 185. Okay. 186, 188, 189, 190, 191, 192, 193. Okay. Okay. So I'll download here also. Okay, thank you all. So we'll meet again tomorrow. Yeah.